In some problems, rather than having the same trigonometric function, for example, the sine of the sine inverse of a ratio, we have something like what we see here, the sine of the secant inverse of a ratio, and we need to find what this expression is equal to. And the way I like to approach these is I identify what is x, y, and r for the problem, and then just set up my ratio accordingly. So for example, let's take a look at the sine of the secant inverse of 2. So for this problem, since we're taking the secant inverse, and we know that this secant is equal to r over x, this tells me that my r value is 2, that's the numerator. The denominator is 1, so that's my x value. And because r has to be positive, always, then since we're taking the secant inverse of 2, 2 over 1 is positive, so the x value has to be positive. So when we have a positive ratio here, we must be working within the first quadrant. And so the x is going to be positive and the y is going to be positive as well. So now what I'll do is I'll find out what is the value of y. And I know that x squared plus y squared equals r squared. That's our Pythagorean theorem. So this gives me 1 squared plus y squared equals 2 squared. And that results in 1 plus y squared equals 4. So then y squared equals 3, and y equals the square root of 3. Okay, so put a square root of 3 in there for y. So now, what is the sine of this angle? Well, it's going to be y over r, which is the square root of 3 over 2. And that's my final answer. So pretty straightforward, not too difficult. Where you can run into a little bit of trouble is where you have a negative ratio here, and then you really have to think about what quadrants are we working with. So in this case, I have the tangent of the cosine inverse of negative square root of 3 over 2. And I know that when we're working with the cosine inverse, we have to be talking about quadrant 1 for positives and quadrant 2 for negatives. So we're working within quadrant 2. And in quadrant 2, the x value is negative and the y value is positive. So I have x is negative square root of 3. Y, I don't know yet because we're working with cosine, and r is 2. So, similar to the last one, I use the fact that x squared plus y squared equals r squared to solve for y, and I take negative square root of 3 squared plus y squared equals 2 squared. And if you realize that this is going to be one of our standard angles that we usually work with, then you'll realize that y has to be 1, but otherwise you can just go ahead and finish solving this. And we get y squared is 1, and so y has to be positive 1 because, again, we're working in quadrant 2, and so y is positive in quadrant 2. So now we're going to take the tangent of this angle. So I'm going to put y over x, and that's 1 over negative square root of 3. And when I simplify this and rationalize the denominator, I get negative square root of 3 over 3 for a final answer. And that's how you solve those problems.